Welcome to another practical application of life sciences. This is Mrs. DeVos, and today we are going to work with chicken eggs. A chicken egg consists of a shell on the outside, albumin proteins on the inside, and egg yolk. In this experiment, we're going to use chicken eggs to demonstrate the processes of diffusion and osmosis. Diffusion is the movement of dissolved substances from an area of high concentration to an area of low concentration. Osmosis is the movement of water particles from an area with a high concentration of water particles to an area of low concentration of water particles. For this experiment, what we will need is vinegar and distilled water and some corn syrup. We'll also need a container that can house 2 eggs or have 2 glass beakers ready. You'll need a spoon to be able to remove the eggs from the solutions and some food coloring so that you can distinguish between the 2 eggs that you are using. Place the eggs very carefully into their containers and pour the vinegar over them. This must be left for a minimum of 24 hours. After 24 hours, the eggs can be removed and the last bit of the shells can be gently removed either by hand or, in this case, I used a toothbrush to very carefully scrub the calcium off. Once the outer shell has been removed, the consistency would feel kind of like a rubber ball, which means at this point you can kind of bounce the egg, but not too hard, it can still break. The reason for this is that the albumin proteins have been denatured, kind of like cooking the egg in warm water. The shell of an egg is composed of calcium carbonate molecules, which can very easily be dissolved in acetic acid. We dissolve it in acetic acid. The product is water, a calcium acetate salt, and the carbon dioxide molecules. Carbon dioxide molecules are the bubbles that we observe once we place the eggs in the vinegar, and these bubbles will eventually evaporate into the air. The triple beam balance is an instrument used to measure mass very precisely. Such devices typically have a reading error of about 0.05 grams. Its name refers to its 3 beams, where the middle beam is the largest, the far beam of a medium size, and the front beam the smallest. It's important to determine the weight of the eggs before you start with the experiment. After you've placed it in the vinegar overnight, you'll notice that the egg has already swollen up slightly, meaning that there's already water that has moved into the egg. Although it's faster and easier to determine the weight of the eggs on a digital balance, I prefer to use the triple balance scale system. This can make it more visual for the learners understanding the concept of balancing out 2 weights. So we started by moving the 100 grams and found that the egg is much lighter than 100. Next, we started moving the weight at the back, which is 10 grams at a time. 80 grams is still too light, but obviously 90 is too heavy. This means the egg must weigh between 80 and 90 grams. Now we move to the smallest weights at the front, moving them from left to right, adding weight as we move along. The goal of this exercise is to line up the 2 white lines on the right-hand side. Once they've lined up, we know that the weight is what the egg is actually weighing. And in this case, it is 80.3. For the second egg, we repeat the exercise. This one has more of a yellow-orange color, and this one is 84.1. Now in the actual experiment, we place 1 egg in pure distilled water and the other egg in corn syrup, highly concentrated sugar solution. Pure water is a hypotonic solution. while the egg represents the hypertonic solution. And water will therefore move from the hypotonic solution into the egg, causing the egg to swell up and become heavier. In the corn syrup, however, the corn syrup is the hypertonic solution, and the egg becomes the hypotonic solution. This means the syrup will move in and all the water will leave the egg, causing the egg to shrink over a period of time. So after 24 hours, we can clearly see there's a difference in the size of the two eggs. The one in the pure water has also undergone diffusion, causing some of the colored solution to move out. When we weigh it, we see that now it weighs 86 grams, and the one that was in the sugar solution weighed 54 grams. In one of our next videos, we also discuss the role of the membrane and the various other factors that plays a role, like surface area, the diffusion surface itself, the thickness of the solutions, etc. So if you like this, please subscribe and learn more about the wonderful practical world of life sciences. I have a passion for teaching, and I would like to give you as much information about this process as I possibly can. So like it, share it, talk to your friends about it. Also watch a couple of these other playlists that is specifically designed to supplement what you've saw in this one. And I'll see you soon.